So now on the second question, we had this volume of revolution. And the one thing I want to address on this question and the next one is, how do you determine when you look at it whether you're going to be doing cross sections or shells? It wasn't as big of an issue on this one, I don't think. I think most people did cross sections, which is good. But on the next one, people tried to do cross sections again. So let me just emphasize, we are going around the x-axis. So if you're going to do cross sections, you're slicing up the axis of revolution, right? That's how cross sections work. Both these functions are functions of x. So right off the bat, that gets me thinking I should be doing cross sections because the axis is x and the variable is x. So they match. If there's a mismatch, then I start to think shells. So it is cross-sectional slices. Most people did just fine. I'd like to see more people sketching the picture. I think you're less likely to make a mistake with the sketch. But there's your slice. And the biggest thing on this is actually pretty happy with the way things went here, except for just a little lack of trig knowledge was all that, if you're rusty on your trig, you should definitely go back and look at some of this. But the bigger radius is secant squared. The smaller radius is tangent squared. That was the cross-sectional area. And where people missed points was trying to deal with this and not realizing that they've got an identity right in front of them. Secant squared minus tangent squared is 1. So the integral was simply the integral from 0 to pi over 6 of pi, which made for a very simple integral. So let's talk about how we could get ourselves in a mind frame that this jumps out at us as an identity. So I just previously mentioned that we should all be comfortable with the Pythagorean identity. Sine squared plus cosine squared equals 1. So in our minds, we know that there's this connection between sine squared and cosine squared. That leads to two other versions of the Pythagorean identity. If you divide everything in here by sine squared, you have 1 plus cotangent squared equals cosecant squared. So that is really, there's sort of the main Pythagorean identity, but this is really the same identity just in a new form, right? So mentally, we should be connecting cosecant and cotangent. And this is sort of natural for a calculus student in that, think about your derivatives. Derivative of sine is cosine. So, and the derivative of cosine is negative sine. So you're already thinking of sine and cosine sort of together, and they're together in the identity. The derivative of cotangent is cosecant squared. The derivative of cosecant is negative cosecant cotangent. So there's a connection already in our minds between those functions. Now, I could have divided through by cosine squared instead. And then I end up with tangent squared plus 1 is secant squared. And so if you move that tangent to the other side, you have 1 is secant squared minus tangent squared. So there's our third version. And again, we should, at least in the back of our mind, remember there's this connection between tangent squared and secant squared. Think about your derivatives. Derivative of tangent is secant squared. Derivative of secant is secant tangent. They always tend to show up with each other in these sort of pairs. And so mentally, when I see secant and tangent together in a problem, I immediately start thinking of identities. And that works out perfectly there. So if you have not already, make sure you review through your trig identities. We use them all the time in our integration. So the way I sort of distributed points in this problem, if you got stuck at this, you could still get, I think, 7 out of 10 points. Because if you don't know the identity, it's hard to get past this. But I wanted to see that you could set this up as cross sections. You understand the formula. Another big issue that just came to mind as I was saying that is this is a circle minus a circle, right? So it's pi r squared, so I'll call that r2 for the outer radius, minus pi r squared, right? I saw this algebra misunderstanding a few times was to write this as this is not equal to that. You can't just factor a square out. These two things are not equivalent, right? Just think about what you have to do in algebra. If you have a statement like that, you need to FOIL that out, and you're not going to end up with this. So this is really that cross-sectional area whenever you have a hole there. It is not that. So be careful of that. I see that algebra mistake a lot. Just try and be conscious of that. Draw your pictures. You know, get in the habit of drawing coordinate systems, labeling them. You're much less likely to make a setup mistake if you've got a clear picture of what's going on.